Hello, geometry students. We are working on activity 10, and we're going to do things a little differently and work with these handouts instead. So in activity 10, we're going to use an introduction to quadratic functions. And this is day 1's lesson. We have another lesson for day 2. So a quadratic function in standard form you should already be familiar with. It looks like ax squared plus bx plus c. But this one is set equal to f of x, which can also be like a y. So before we start graphing these functions, let's discover their shape by graphing the most basic function, f of x equals x squared. Okay, so to do that, I'm just going to pick some values to put into our table. So we'll put numbers in like -3, -2, -1, 0, 1, 2, and 3. And let's see what happens when we plug them into our function. So when we plug in each one of these numbers and we square it, it's going to come out as its square. So -3 squared would be 9. -2 squared would be 4. -1 squared is 1. 0 is 0. 1 is back to 1 again. 2, 4. And 3, 9. So these numbers will become very familiar to you because that's what happened when we square our x's. So now we're going to get our first parabola graphed. We have a 0, 0 origin point, and then notice on either side we have a point at 1, 1 and at -1, 1. We have one at 2, 4, and then we have one on the other side at -2, 4. And finally 3, 9. And -9, or -3, 9 as well. And this is the graph of the function f of x, or y equals x squared. The graph of a quadratic function forms a parabola. And the graph of f of x equals x squared is also shown here on the left. And for this function, a is equal to 1. It's just 1x squared. And the parabola is opening, we say up, since it's facing in the upward direction. Okay, so we want to look first and see what happens when we change values of a. So when a is something other than 1. Okay, so if we look at each one of these graphs, we can kind of see. In our first function, we have f of x is 7x squared. Okay, so 7x squared, notice our graph got very narrow, although it's still facing up. When a is 7, the graph still opens up, but it got very narrow. In graph number 2, notice that a is 1/7. Well, this graph still opens up, but the shape got wide. In graph 3, we have a is -7, -7x squared. The graph opens down, and the shape is narrow. And finally, in our last graph, we have a is -1/7, so down and wide. So if we compare these graphs with each other, notice that when a is positive, the graph is opening upward. When a is negative, the graph is opening down. Okay? When a, or the absolute value of a, is greater than 1, okay, then the graph gets narrow. But when the absolute value of a is between 0 and 1, or a fraction between 0 and 1, notice it got wider than the normal graph. Okay, that's just something to pay attention to. Now we get to our next part is to help us learn how to graph a function from standard form. We need to be able to locate what's called the line of symmetry. So every graph of a parabola has symmetry. And that line of symmetry is going to help us determine the vertex of the graph. So in this case, the line of symmetry it's a vertical line. And that vertical line crossed the x-axis right here. And that is at the point 4. It's crossing at x equals 4. And so the line of symmetry is x equals 4. Now the vertex lives on the line of symmetry, and it's actually right here at the point 4, -7. Okay, now we have a shortcut way that we can find the x value of that vertex, or we could find the equation of the line of symmetry. So you're going to want to remember this little formula right here for the line of symmetry. It's x equals negative b over 2a. And it's just a little formula that will help you discover the line of symmetry and then use it to find the y value of the vertex. For example, in this problem, negative b, so it's negative, and then b, of course, is up here. b is -8, so negative 8 over 2 times 1 was 8 over 2, which is 4. That was our x value of our vertex. When you plug that back into the function, so f of 4, you get -7 out, and there's where our vertex is. So we're going to practice that right now. Okay, so our line of symmetry, we don't really need the formula for this one if we can use the graph, but we're going to practice the formula and then we'll verify it with the graph. So in our first equation, our a is 2 and our b is 4. So if I use the formula x equals negative b over 2a, I can plug in -4 over 2 times 2, which is -4 divided by 4, or -1. So x equals -1, and that makes sense because here's my line of symmetry. Okay, so we can verify it with the graph. Now to find the vertex, we plug in -1. So we want f of -1, which will be 2 times -1 squared plus 4 times -1 minus 1. So that is 2 times 1, which is 2, plus 4 times -1, which is -4, minus 1. So -2 minus 1 equals -3. So our vertex is -1, -3, which we can verify on the graph right there, -1, -3. Let's try another one. This time, our a is a little messier. It's -1/4. And our b is 1. So x equals negative b over 2a, and so that is going to be -1 over 2 times -1/4, which is -1 over -1/2. When we flip and multiply, we get +2. Okay, so our line of symmetry is at x equals 2. Which means it's going to go right through here. Okay. Now, when we get 2, we can plug it into our function, -1/4 times 2 squared plus 2. So that's 4, -1 plus 2 equals 1. So our vertex is 2, 1. And we can verify it on the graph right there, 2, 1. Okay, we'll do one more. Just to practice, let's try our a this time is -1. Notice the graph's upside down. B is actually 0. So when we do x equals negative b over 2a, we have -0 over 2 times 1, or 0. So our line of symmetry is x equals 0, which is actually the y-axis. Now if we plug 0 in for x, -0 squared plus 4, we just get 4. So 0, 4 is our vertex. Right, there's one more thing that we want to know about quadratic functions, one more attribute that we're going to study, and that is the min or the maximum value. And the maximum or minimum value is the y-coordinate of the vertex. And this value simply tells us how high or how low the parabola goes. So in our first problem, we can see that the minimum is at -3, and that the maximum for this other one is at a high of 1. Now with all that together, we can do some practice graphing. So the first thing we're going to want to do in every graph is get the vertex so that we know what kind of numbers to put in our table. Okay, so this graph should open up. And the reason it should open up is the a is positive. It's 1x squared. And since a is just 1, it should be a normal width. All right, let's do the axis of symmetry first. So we can do the x equals negative b over 2a first. So that's negative 6 over 2 times 1, or x equals negative 3. So our line of symmetry, they're calling LOS, that's our symmetry line. And so we're going to put our x equals negative 3 here. And to finish our vertex, we're going to plug that in. So f of negative 3 is negative 3 squared plus 6 times negative 3 plus 4. So that's 9 minus 18 plus 4, which is negative 9 plus 4, which is negative 5. So negative 3, negative 5 is our vertex. So the best thing to do is stick that number in the middle. Okay? Because then you can pick values around it. That's where the symmetry is going to occur. So the symmetry is going to be at x equals negative 3. So 1, 2, 3. Okay, and then our vertex is also going to live on that symmetry line, and that is going to be at negative 3, negative 5. Okay. Now all we have to do is put in numbers around it. So numbers like negative 4 and negative 2. I should say, let's put negative 5 in that spot. We'll put negative 2 on the other side. Yeah, we'll put negative 2 here and negative 1 there. And when you plug those numbers in, we'll be able to see what we get. So these are usually best done on your calculator, so you can do them quickly. So if I do negative 5 squared plus 6 times negative 5 plus 4, we're going to get negative 1. Okay. Now if we put a negative 1 in there, you're going to notice that we also get negative 1, and that's because of the symmetry. Same with negative 2 and negative 4. You really just need to test one of those. Negative 2 is going to give me a negative 4, so negative 4 will also give me a negative 4. So our graph is going to have ordered pairs at negative 2, negative 4, there, with a buddy on the other side for symmetry, negative 1, with a buddy on the other side for symmetry. And now we have a good graph. Okay, we'll do one more, and then that should be enough for this video. We'll save the others for practice in class. Let's do the next one. So we are going to look at finding the line of symmetry first for our graph, and we're going to use our negative b over 2a. Okay, so negative 4 over 2 times negative 1 is 2. So x equals 2. That means my vertex is 2 something. So we'll plug that in. Negative 2 squared plus 4 times negative 2 plus 1. Oops, I plugged in negative 2. I needed to plug in 2. Let me fix that. And we get 5. So 2, 5 is our vertex. Okay. And this graph is going to open down because it has a negative a value. So that means 2, 5 is going to be a max. Whereas over here, our negative 3, negative 5 was a min because it was the lowest point of the graph. Now we'll pick numbers around 2, so 3 and 4, 1 and 0. We could plug those numbers in, we'll have a good graph. Okay, if you put 0 in, we'll get 1 out. So we'll get 1 out when you put 4 in. If you put 1 in, you're going to get 4 out. So if you put 3 in, you will also get out 4. So now we can make our graph. Remember, that's your line of symmetry. Okay, plot your other points. So we plotted 3, 4, and we plotted 1, 4, 0, 1, and 4, 1. Now you can see this graph is upside down. Okay, but again, it's going to have the normal width because the a value is -1. So the absolute value is just 1. All right, let's do one with one different width just to practice that one. So let's do the third one. Going to start with the line of symmetry, of course. So x equals -b over 2a. So -b over 2a is -4 over 2 times 1/2, which is just 1. So we'll get 4 over 1, which is 4. So our line of symmetry is x equals 4. Okay, which means that's the x value of our vertex. Okay, now this graph is going to open up because it's got a positive a value, and that means our vertex is going to be a min. But now let's figure out what we get when we plug in 4 to our function. So if I take 0.5 times 4 squared minus 4 times 4 plus 5, I get -3. And that goes in the middle of our table, 4, -3. So then we can put 3 and 2, we can put 5 and 6. 1, 2, 3, 4. 1, 2, 3. There's my vertex. There's my line of symmetry. Now I just need to plug in a few other numbers and I'll have it. So if I plug in 3, I get out -2.5, which means 5 will give me -2.5. If I put in 2, again, I'm just putting these into my calculator, I get out -1. So this graph is growing a little bit more slowly. Okay, so at 5, I'm at -2.5, so I'm right there with a match on the other side. At 3, -2.5. 2 gives me -1, and so does 6. So this graph is going to be wider than the norm. Again, that's because the a is between 0 and 1. All right, we'll save the last one to do together in class.